Oracle built-in functions. Let's start Oracle built-in functions by taking a look at the different functions available. The types of functions. The first type we want to look at is a single row function. A single row function implies that the function is applied to each row in a query. For instance, as you can see in the example, I've selected the name twice from the category table and I've executed uppercase on the name in the second column. All this means is that every category row selected from the category table will have the function upper applied to the name field. So the single row function implies that the function is applied to every row selected from the category table. A subsidiary of single row functions are data type conversion functions. Data type conversion functions do literally as they say. They convert between data types. In other words, they convert from characters to numbers, vice versa, and dates to characters, etc. As you can see from the function here, is I've taken a number at 1 million, I've applied a format to it, which is comma delimited, and I come out with a character value of 1 million delimited by commas. The next type of functions are group functions. Group functions literally group things. They take groups of rows and add them together and apply a function to the group. So what we've done here is we've actually selected all the records from the category table and counted them. Really what we're doing is we're taking all the records, grouping them together and counting the resulting number of rows. Object reference functions are another category of functions where a reference value can be used to find the value of an object in an object table. User-defined functions. A user-defined function is a function created or defined by a user. Here we can see a function here which says create or replace function F to C, Fahrenheit to Celsius, pass in the Fahrenheit value, return the number as Celsius. This return statement internally within the begin-end loop executes the calculation. Let's go and take a look at this SQL function in SQL+. What I have here is a procedure submitted to the parser and compiled. Then I have two commands which set the server output on and enable DBMS output with a large buffer. I then execute the procedure a number of times, passing in various Fahrenheit temperatures and passing out various Celsius temperatures. I then switch the server output off and disable the large buffer in DBMS output. Set server output on allows the output of put line, new line, etc. functions from the DBMS output procedure. Without set server output on, you will not get any output from DBMS output in the SQL Plus window. Executing the enable function with a 1 million character buffer simply resizes the buffer up. The default buffer with DBMS able is actually very small. So what happens when you run out of space in the buffer from executing lots of put lines is you get an error return from the procedure. What happens with DBMS output is that it will only output the result at the end of a SQL statement. By SQL statement, I mean if you have a very large stored procedure with a lot of output, a lot of DBMS output commands inside the procedure, it will only dump out that output when the procedure completes. If it's large and it puts out a lot of information to DBMS output, you could run out of space. The resulting problem with the buffer running out of space causes the procedure to crash. It won't crash the database, but the procedure will just abort and you'll get no result. So remember that. Set server output on. Enable the DBMS output buffer. Make it big. The maximum size is actually 1 million bytes, which is what we have it set to here. It's about a meg. It's big enough. Remember to disable it afterwards to switch it off because it's chewing up a sizable chunk of memory. Set the server output off. You don't necessarily need to do that, but you don't necessarily want it on. What you can see here is that the Fahrenheit to Celsius calculator involves taking 32 away from the number of Fahrenheit and multiplying by 5/9. So here we actually have the function in PLSQL. We've taken 32 off. We parenthesized it to make sure of the precedence because the multiply has higher precedence than minus. We don't necessarily need the parentheses around the 5/9 because multiplication and division should have the same level of execution. And what we've done at the end is we've rounded the results so we don't get a huge floating point number. Now let's deal with this procedure step by step. Let's first of all take the actual procedure creation and copy and paste it. So we're logged into concerts. We're going to create this function. Now what it's actually done at this stage is it's submitted the function and it's compiled it as well. I generally just compile it anyway, just to make sure. And now we'll execute the procedure. And we get lots of results. 50 Fahrenheit is 10, 70 is 21, 90 is 32, etc., etc. 32 is 0, which is freezing. What's the point of all this? The point of all this is there is no function in Oracle that does this, obviously. Why would you need a Fahrenheit to Celsius converter? The point of all this is that you can build your own functions. How the function is coded, the syntax, all that sort of stuff to do with PL/SQL, we will get into much later on. For now, you know that you can create your own functions. Let's go and take a more detailed view of some of the types of functions. Single row functions, string functions. String functions do things with strings. They take in strings and they pass out strings. A string is a piece of text, a number of characters. In this case, I've got the function initCap, which means set the first letter in each word in the string to a capital. So lowercase my name is Joe becomes my name in Joe with the first letter in each word capitalized. Number functions. Number functions do things with numbers. For instance, as we have here, we're raising the number 2 to the power of 3, which means 2 times 2 times 2 is equal to 8. 2 times 2 is 4, times 2 is 8. Dates. Date functions do things with dates. For instance, add months. Take the date 18th of January 2003 and add 3 months and we get the 18th of April. Other functions. There are other or miscellaneous functions, many of them, which do not necessarily do anything with numbers, strings or dates, not specifically or explicitly anyway. Here we have an example called NVL. NVL simply replaces null values with the specified value, which can be a numeric or a string. Data type conversion functions. Once again, the same function, converting the number 1 million to a character string, passing it through a comma delimited format, gives me the number 1 million delimited by commas. Let's take a look at group functions. We will deal with group functions later on when dealing with the group by clause. At this point, I just want to describe what they are and what they do. There are actually 2 types of group functions. The first one is an aggregate group function. The second one is an analytical group function. Now, the most simple difference between the two is that the aggregate will produce a single row, whereas the analytical function will actually produce a number of rows. However, the aggregate produces a group in the same way that the analytical function actually produces multiple groups. All it does is that the analytical function breaks the single group into a number of subsets. As you can see from here, once again, we've selected the count from the category and we've come up with 34 rows returned. The analytical function actually analyzes data, groups it into sections, and it would return multiple rows per group, but it would not necessarily return a single row from a summary of multiple rows. Let's take a detailed look at string functions. Here we have a string function, initCap, which says change all the first letters in each word to uppercase. Pass through the initCap function, gives me my name is Joe. Let's try out that initCap function. And let's try select initCap name from category. We note, for instance, that children's music and theatre is all uppercase on the first letter of each word. If we select, once again, name from category, we find that it actually changed the word and. It changed the S after the apostrophe because it assumes that the S is actually a word by itself. That can probably be avoided by using escape sequences and escape characters on the quote character, because Oracle actually uses a quote as a language interpretation command as a string delimiter. So, string functions. Here are all the string functions currently available in Oracle. The ones that are highlighted in red are generally the ones that I use often, and the ones that we're interested in. The ones that we're not interested in at this stage are generally the national language character set functions, SoundX, which does something odd and returns phonetic representations of words to do with sound. ASCII and char deal with conversions between binary and character values, and the treat function does things with data types. So let's get back to the red ones. These are all the red ones. Let's look at them in detail by example. Concat. Concat expression. This means that you put two expressions or strings delimited by a comma into the concat function. The concat function concatenates or sticks two strings together. Let's look at an example. I have a large number of examples which I've typed into a SQL file, and I'll use these to demonstrate all of these string functions. So let's go through them one by one. The concat function. I've got two names, actually a first name and a last name, and two separate strings, and I'm simply concatenating them into a single string. Obviously, it probably would have looked better, since this is a name, if I'd done something like this. And there we have it. Concat toChar category ID and name from category table. It simply concatenates the values. We could make that even better by saying select concat toChar category ID and what I was thinking of actually doing is this. Let's embed them. So we have toChar category ID, convert it to a char. We need to concat that to a comma, and then we need to concat the result to the name column from category. And there we have what could effectively be a comma delimited file, if we were to output it to a spool file, etc. There's a much easier way of doing that, of course. We can simply say, in fact, we probably don't even have to use the toChar function, because there will probably be an implicit type conversion. You've seen me use this in the past, where I have a single concatenation using these double pipe commands. I needed to use two concat commands embedded within each other because I had three items to concatenate together. But I showed you how to embed things. You can embed functions. One function can call another. That's what I mean by embedding. So that's concatenation. Initcat we've already seen. InString. InString takes an expression, it searches for a substring from a position and for an occurrence. Let's look at some examples. Here I have three example uses of the InString function. I'm going to search in the first one for the word is in the string, this is a string. In the second example, I'm going to search for is, but I'm going to search from position 1, and I'm going to search for the second occurrence. So actually in the first one I'm going to find this string here, in the second one I'm going to find this string. Here I'm searching for the letter A, so I'm probably going to find this one. Well, not probably, I'm definitely going to find this one. Let's verify this. Let's copy and paste these, and we're back in SQL+. Let's paste these three statements. And we say, find the word or the string is in this is a string, and we find in position 3, which is THI, 1, 2, 3. Here we have go and find the second occurrence of is, which is this one, 1, 2, 3, 4, 5, position 6. Here we're finding the string A, since a single character is technically a string, even though it's one character, and we find 1, 2, 3, 4, 5, 6, 7, 8, position 9. That is how in-string works. The length function. The length function is very simple. It simply gives you a length of a string in terms of the number of characters. So we select length name from category, and we find all the lengths of all those strings. We could go a little further and simply print the name selected from category, and we could verify that. Tennis, T-E-N-N-I-S, 1, 2, 3, 4, 5, 6 characters. Wrestling is 3 more. Ballet and dance is 3 more than that. The lower function, another very simple function. Lower simply converts all the letters in a string expression to lowercase. And here's a SQL statement using the lower function. Everything in the category table is converted to lowercase in the select statement. The left pad function. The left pad function will pad a string from the left with a specified character or expression, string, etc. Let's try an example of the left pad function. I'm going to pad this string, a string, which is 8 characters long, up to 10 characters, from the left with the character x, and we end up with XX a string. Left trim. Left trim will do the opposite of left pad in that it will remove from the left of a string a set of characters, not an expression, which is a single result, as in one character and many characters. Left trim will look through the string set, as in A, E, I, O, U, and remove all the characters from the beginning of the string that are in that set. In other words, it will take all the A's, all the E's, all the I's, all the O's, and all the U's, all the vowels out of the word, until it finds something in the expression from the left which is not one of those characters. So let's demonstrate. What I've done here is I've gone and taken space A, E, I, O, U from is this a string. The first character I find that matches is I. The second character is an S. It does not match, therefore the left trimming stops. My result is the phrase, is this a string, without the I on the beginning of the string. Replace. Replace can be used to replace search patterns or strings within other strings. Here's a simple example of replace. All we're going to do is we're going to find the letter A in the name column from the category table and replace it with 3 asterisks. So, ballet, dance would be replaced with ballet, 3 asterisks, and 3 asterisks included within the word. Classical opera, theatre, etc. Right pad. Right pad does the same thing as left pad, except it pads the string from the right. So let's do the same thing with right pad that we did with left pad and replace or pad the string up to 10 characters long with the character X. And now we can see that the X's are on the right. Right trim. Once again, right trim does the same thing as left trim, except it does it from the right of the string. What I'm doing with right trim here is I'm going from the right of the string and I'm trimming all G's and spaces from the right side of the string. The first character I find is a G. The next character I find is an N. It is not a space or a G, so the right trimming stops, and I end up with the string with the G chopped off the end. The substring function. The substring function is used to find substrings within expressions, within other strings, from certain positions for certain lengths. In other words, you extract a chunk within a string. It's as simple as that. Here's a very simple use of the substring function. I take the category name field and I take a substring of that name field from the 5th character for 10 characters. As you can see, I've chopped off a lot of characters. We could make that a little bit more visual by also selecting the name field from the category table. And we can see that we've taken ski passes and we've pulled passes. It's important to note that substring starts at 1, 2, 3, 4, 5th position 5. Rodeo, rodeo. 1, 2, 3, 4, 5 is the O. The translate function. The translate function. The translate function is used to literally translate a set of characters to other characters. In other words, switch one character to another. I have a few examples with the translate function which lead from simple to more complicated. The first one is going to take all lowercase vowels in the category name field and replace them with uppercase vowels. So let's execute that one. And all I've done is I've taken all the vowels and uppercased them. My second example simply takes all the consonants which are uppercase and converts them to lowercase. So let's execute that. As you can remember, all the names in the category table were all uppercase on the first letter of each word. What I've done is I've lowercased every single letter at the beginning of each word. Now what I'm going to do is I'm going to apply that translate function by executing the first translate by changing the vowels to uppercase within the second translate, which changes all the consonants to lowercase. I'm going to execute the one function inside the other, and I'm going to change all the consonants, since only the first letter in each word being a consonant is uppercase. I'm going to change all those consonants to lowercase, and I'm going to change all the vowels in those words to uppercase. The trim function. The trim function is much like the left and right trim functions. By default, trim will trim an expression, and it will trim spaces from the beginning and the end of the expression. It can also be used to, say, trim leading character from expression or trim trailing character from expression, which is exactly the same as left and right trim respectively. Both will trim all characters from an expression from the beginning and the end of the string. Let's look at some examples of the trim function. Let's go back to the first one. What we've done here is we've trimmed everything from the string. By default, it will trim both from the beginning and the end. As you can see, we've removed the spaces from the beginning and the spaces from the end of the string. The default trim character is a space. The second example trims the leading spaces from this is a string and gives me this is a string with spaces. This left trim function actually does exactly the same thing as select trim leading spaces from this is a string. As you can see, the result is the same. Here I've used select trim leading space from, and here I've used select left trim. The next example is to trim the trailing characters, trailing blanks from spaces, this is a string, spaces, and I get this is a string with all the leading space characters and no trailing space characters. Exactly the same thing can be done with the right trim character, removing spaces from the same string, and we get the same result as we do with select trim trailing characters from the string, as in spaces, this is a string, and no trailing blanks. The last form of the trim function is to trim both. In other words, trim not only leading or trailing, but both leading and trailing characters from the string. The result is the string, this is a string, with no leading space characters and no trailing space characters. The last function we will look at is the upper function. Exactly the same thing as the lower function, except the opposite way around. All you do is you pass a string through upper and it converts every single character to an uppercase character. So, an example of upper would be to take the name from the category field and pass it through the upper function. So here we have tennis converted to uppercase and theatre, etc., etc. Now let's take a look at one or two interesting examples which combine functions. We won't get too complicated at this stage, but let's just try one or two. What this example does is it uses the replace function to replace a front slash in the category name field with the word space and space. So instead of country front slash folk, we actually get country and folk. Let's restructure that statement a little so that we can see exactly what's going on here. From the category where we actually had a where clause that only retrieved category names which had the front slash in them, and we used the inString function to verify that the name field had the front slash. So that's why we only found 6 rows. Let's run this statement again. Now we can see we have country slash folk replaced with country and folk, etc., etc. Here's an even more complex example. What are we doing here? We've got multiple instantiations of different functions: substring, instring, length, and instring. Typically the substring function is used to do some odd things and extract parts of strings based on the lengths of strings and characters within those strings. In this case, what I've done is I've gone and found all names in the category table with the front slash, and I've found the word after the front slash. So here what I did was I said select substring from the name field in the category table from the position of the first occurrence of the front slash plus 1, because it starts at 0 and substring starts at 1, and then I said for the length of the entire category name, and I subtract the position of the front slash character. So what effectively I do is I say take the substring of the name from this front slash, for the length of this name, subtract this position. So I actually extract the word folk from country slash folk, and there we have folk. Number functions. Here's an example number function we've already seen. Power 2, 3 raises 2 to the power of 3, which means 2 times 2 times 2 is 2 times 2 is 4 times 2 is 8. Let's look at all the number functions. The functions highlighted in red are the ones we're interested in at this point in time. The ones highlighted in black we're not terribly interested in right now. They're mostly trigonometric functions such as sine, cosine, tangent. They're opposite number arc functions, as in arc sine, arc cosine, arc tangent, the hyperbolic functions, and various others. Let's look at ABS, seal, floor, mod power, round, sine, square root, and trunk. What do they do? ABS. ABS is an absolute value function. Seal is a ceiling function. In other words, you take a real number, which is a number with decimals, and you round it up to a whole number. Floor does the opposite of ceiling. Mod is a modulus or remainder function. Power, we've already seen, raises a number to a power. Round will round a number off to a certain number of places. By rounding, mathematically, we mean that a decimal that is 0.5 and over is rounded up, and a decimal that is less than 0.5 is rounded down. The sign simply gives you whether the number is positive or negative. A negative number will give you -1, a positive number will give you +1. This is a square root function. Square root of 4 is 2. Trunk function is truncate. Truncate is slightly different to round in that it doesn't round up or down based on 0.5, it simply chops off the decimal. Now let's go and take a look at a few examples. Here I have a script file where I've typed in a number of examples, generally 1 or 2 for each one of the functions. All I'm going to do is I'm simply going to copy and paste these select statements using the functions into SQL+ and show you the results. Let's start with the absolute value function. So let's copy and paste these 2 lines, go to SQL+, and paste it. As you can see, absolute value -1 gives you +1. Absolute +1 gives you 1. Mathematically, the absolute value function simply gives you the positive value for either a negative or positive number. And obviously 0 will give you 0. Now let's take a look at floor and ceiling. So we'll copy and paste this, we'll go to SQL Plus and we'll paste this in. As you can see, 2.4 is actually rounded up to its ceiling value of 3. 2.5 is rounded down to its floor value of 2. Note, mathematically rounding 2.5 would actually normally give you 3 and 2.4 would normally give you 2. The ceiling function forces it to go upwards regardless of the decimal, and the floor function forces the number to go downwards regardless of the decimal. Now let's try the modulus. As we said, the modulus is like a remainder function. All we're doing is we're saying 3 divided by 2 gives me 1 plus a remainder of 1. So if we did select mod 10 4 from dual, we would actually get an answer of 2. What's happened is we've divided 4 into 10 twice. 2 times 4 is 8. 10 minus 8 gives you 2. Now let's use the round function. We've got a rounding on 10.123 to 0 decimal places. It gives you 10. If we were to do select round 10.1, 10.5, 0 decimal places from dual, it will round up to 11. Here we see we've done 10.125 to 2 decimal places. Because the 5 is there, the 2 will be rounded up to 3, so we get 10.13. The opposite is true of this one, where we've gone 124. The third decimal place will round down to 12. Now let's look at the sign function. The sign function will simply give you -1 or +1 depending on the sign of the number. And obviously 0 will give you 0. The square root function will give you the square root of the number. That is 10 times 10 is equal to 100 and 2 times 2 is equal to 4. The trunc function works differently to the round function in that it truncates. What do we mean by truncate? Truncate means chop off. It means do not take. For instance, in this case, do not take these decimals into account. There is no rounding. All it does is simply remove them. So what happens in this second example, where the round function would take the 5 and round this up to 13, it simply chops it off. So you get 10.12. The same applies to 10.124. Rounding up and down is irrelevant, and it simply chops off 124. Date functions. Let's take a look at the date functions. Add months in this case takes 18 January 2003, adds 3 months, and comes out with February, March, 18th of April 2003. All the date functions. Once again, all the ones I'm interested in are marked off in red. The black ones I'm not even going to discuss at this point. What do these date functions do? What I've done is I've divided the date functions up into 3 separate sections. I call them dates and times, date manipulation, and rounding and truncation, literally the round and trunc functions. Let's go back to dates and times. I have 5 dates and times functions. All I'm going to do is I'm going to take some examples from a script file which I've previously written, and I'm going to copy and paste them into SQL Plus. And here we have it. What results do we get from here? Current date and sys date. There is a difference between the dates such as sys date and current date, or sys timestamp and current timestamp. Generally, the current implies my local session, such as on my client machine, and sys implies my database server. So going back to my SQL Plus window, there's obviously no difference between current date and sys date here. However, if you look at current timestamp, -5 GMT, and sys timestamp minus 8 GMT. That means that my local client machine is on minus 5 GMT, which is Eastern Standard Time, and my database server is actually set to Pacific Standard Time because it's 3 hours behind. Minus 5 is Eastern Standard Time, which is the Eastern Time Zone for the United States and most of North America. Minus 8 hours is Pacific Standard Time, which is 8 hours less GMT, which is West Coast time for North America. The other example I have is local timestamp, which simply gives me a timestamp without the time zone. So we've seen what the dates and times functions do. Let's go on to date manipulation. I've got some examples for these. Let's look at add months. And we'll paste in some add month functions. And here I've added 5 months to 12 December 2002, and I get May, which is the 5th month of 2003. What I've done here is I've got an error. So we can simply correct that, and we can add some months to sysdate, which is January, and we get March. Add months simply adds a number of months to a date and returns a date. Last day. The last day function returns the last day of the current month. So let's demonstrate this by finding the last day and the month of my sysdate. My sysdate is actually set to January 03. The last day in this month is 31 January 03. Months between. Months between simply finds the number of months between two dates. So let's use months between and paste them in. So what I did was I took sysdate and I subtracted a year. And I said, what are the months between sysdate and sysdate minus 365 days? A year is 12 months. And then I took sysdate and I added 128 days, and I come up with 4.2580645 months. Next day requires the input of a date and a weekday, the name of a day. So if I were to put in, for instance, next day Monday, since my current date is the 21st of January 2003, it's a Tuesday. For some reason I have an invalid argument there. The reason is that I didn't put a date in. Now that would certainly help, would it not? So let's put in sysdate, copy and paste this. What we get is 27 January 03. The date today is the 21st. It is a Tuesday. I'm looking for the following Monday. Therefore I get 21st plus 6 days, which is 27 January. My next set of date functions, rounding and truncation. Once again, rounding rounds up or down, and truncate simply chops off. Let's take a look at some examples. I have a number of examples here, and each one has both the round and truncate. Some will come out the same, some will come out differently, depending on what my current date is. Here I've added a number of days to the sysdate to give me a different answer. You'll notice that I have formatting in all these rounding and truncation queries. Why is this? As you can see, the functions are declared syntactically as date with an optional format. What are these formats? For rounding and truncation functions on a date, one places in a single format specifier which tells the trunc and round functions how to round or truncate the dates. In other words, round or truncate to a year, a month, a day, etc., etc. We won't go into the details of these formatting functions at this point. If you want to find out what all these format specifiers mean, go into the documentation on TechNet Online. All I'm going to do at this stage is to take you through some examples. So let's take the first one and round and truncate to y. What does this give us? This gives us a date rounded to a 4-digit year. As you can see, since we're on the 21st of January, and we're only in the first month of 2003, the round function has rounded down. The same applies to truncate. It does the same thing as round because it chops off and it comes out with the 1st of January. The second example, we'll do something slightly different because what we've done is we've ensured that our sysdate, or the date that we're going to round and truncate on, plus 300, will be past the middle of the year. So what happens is that round will actually round upwards to the first day on the beginning of next year, 1st of January 2004, and truncate will again chop off and effectively round down. Our next example uses the month format specifier. And all we're doing here is, because we're 21st of January, past the middle of the month, we round up to the beginning of February. Truncate again, rounds down or chops off to the 1st of January. Our last example, we'll look at the quarter. These results will be identical because we are in the first quarter and we are before the middle of the first quarter. So round will round down and do exactly the same thing as truncate, chopping off. Other functions. Other functions or miscellaneous functions. These are functions that are provided by Oracle which cannot really be classified as date, number, or data type conversion functions. Data type conversion functions we will see shortly. What is this example? This example is the NVL function, which effectively replaces a null value with another value. When you find a null, replace it with something such as this is a null. What are all the other or / miscellaneous functions? These are all the miscellaneous functions. The ones I'm interested in at this point in time are the ones highlighted in red. As you can see, there are a lot of them. What does bFileName do? bFileName returns a pointer associated with a binary object in the database. We don't have any examples of that in our concept schema, so we won't look at an example of bFileName. Just as a side issue, generally the most efficient way of storing multimedia objects in a database, not only in a relational database but in an object database as well, is to store the file on a disk externally to the database and store a pointer to that file in the database itself. You don't want to store the entire binary object within the logical structure of the database. It's much more efficient to simply store the pointer and then store, for instance, the image externally. The only circumstances under which you would not want to do something like that, where you would want to actually store the object itself in the database, is where that object, such as the image, is changing frequently. Enough about the files. The coalesce function. Coalesce will simply coalesce all nulls out of a query or an expression. Decode. Decode is like a case statement. It allows you to change one value to another. The best way to explain decode is by example, so we'll get to that in a minute. Greatest returns the largest value in a list of expressions. Least does the opposite. Null if really does exactly what it describes. It says null if these expressions. In other words, return null if these two expressions are the same. NVL we've already seen. We replace a value in an expression if that expression result is null. User. User will simply return the username of the current session. Now let's take a look at some examples. What I've done once again is to type in a list of examples using all the functions. So let's take a look at the miscellaneous functions. Let's start off with coalesce. Coalesce finds the first item in a list of expressions which is not null. Null, null, A. A is the first value. Now what we're going to do is we're going to look at the decode function. What the decode function does is it reinterprets a value into another value for a list of consecutive values. What I've actually decided to use is the user constraints view. First of all, let's go and describe the user constraints view. What we have is constraint name, constraint type, and table name. I'm going to use those three columns. This is what I'm going to use in general for my decode example. The first thing I'm going to do is I'm going to go and look at the constraints view and see what we have in there, in the concepts user. What we have is table names down here, the names of the constraints, and the type of the constraint. The type of the constraint is listed as a single character. What I want to do is to reinterpret those single characters into something sensible. Let's make a quick check on the user constraints view to see what we have. The distinct function will go through this column and select individual or unique values from here. In other words, as you can see, we've got two C's. It will give me one C, and it will give me one P, one R, one U, etc. So it selects the unique values or distinct values from the constraint type column in the user constraints view for the concepts user. Unique values we have are C, P, R, and U. Now what we can do with the decode function is to decode C, P, R, and U. Now I know that the constraint type P represents a primary key. The R type represents a foreign key, as in reference. U represents a unique key, and C represents a check. Since I'm looking at referential integrity values or constraint types, I'm not interested in checks, so I'll use the default. So what I do, how I decode is to say decode the field called constraint type. If I have P, reinterpret to primary key. If I have R, reinterpret to foreign key. If I have U, unique key. If I don't have P, R, or U, I will simply default to the unknown value. The last value is always the default. The first value is the value that I want to decode from. So let's run this query. And here I have it. Here's, for instance, my venue table at the bottom. It has 3 indexes. The first one is unknown, which implies it's a check constraint. The second one is a primary key on the venue ID. And the third one is a unique key called AK venue underbar 1. Let's take a look at another table, for instance the category table. The category table has an unknown constraint type, which is a check constraint, probably a not null constraint, and has a primary and foreign key. The primary key is the category ID, and the foreign key is the parent ID to the category ID, the self-join. For instance, the show table has a lot more constraints since it has 3 foreign keys and a primary key. It has 4 check constraints. These are probably all not null constraints on all the keys, the primary and the 3 foreign keys. So that's the decode function. Let's look at greatest and least. So we're going to copy and paste these examples into SQL+. You can see that greatest returns the greatest value of 1, 2, 3, 4, 5, which is 5. Least returns the least value of the words 1, 2, 3, 4, 5. Why is 5 the least? Because alphabetically 5 is less than 1, 2, 3, 4. First of all, F comes before O, T. Also, the I in the second letter of the word 5 comes before the O of 4. Therefore 5, the word 5, is the least value amongst all these words. Now let's take a look at null if. As you can see, Since the two values are the same, it will return null. Since these two values are different, it will not return null, but it will return the first value. The NVL function. As you can see, what's happened here is that for my null show dates, which are appearing at the end of my query, I've actually replaced them with the sysdate value. So the NVL function, when it encounters a null value, replaces it with whatever you specify. The last example is select user from dual, and it simply tells me which username I'm logged in as. That's all the miscellaneous functions and what they do and how they work. Data type conversion functions. Here is an example. To char the number 1,000,000 to a string representation which is comma delimited. We end up with the number 1,000,000, comma delimited in thousands. Here are all the data type conversion functions used in Oracle. The only ones we're interested in at this point in time are toChar, toClob, toDate, and toNumber. toChar converts to characters from numbers or dates. toDate converts from a character to a date. toNumber converts a string to a number. toClob actually converts a text string into a text binary object. Before I go into some examples, let's just go through all the data type conversion functions we want to deal with, the red ones. toChar converts an expression, applies a format, and returns a string. Here are some of the number formatting specifications that can be used. Comma delimited, dollars, decimal points, zeros in front, straight numbers, etc., etc. Here are some of the date formatting specifiers. toNumber. toNumber simply takes an expression and converts it to a number. toDate. Again, an expression converted to a date applying a specific format. toClob simply takes a string and puts it into a binary text object. Now let's go and look at some examples. The first two examples. This number has a thousands comma delimited format applied to it. This date has this format applied to it. So the date changes from this to this, day/month/year. The next set of examples. This number has this format applied, round to 2 decimals. The 3 in this number is rounded to 2 decimals. Since it's below 5, it's rounded down. The result is 102.12. This number has this format applied, no decimals. That becomes 0. This 0 replaces the empty value with a 0, so a 0 appears. In this example, we're taking 0.1 again, and we're applying 2 decimal places, so the result is 0.10. In this example, the 0 at the end of the number before the decimals has been replaced with a 9. The result is that this 0 disappears. So we have 0.10 instead of 0.10. The last example is filling from the left with zeros. So we chop off, we have no decimals, we have 0.1 becoming 0, and we're filling from the left with zeros up to 1, 2, 3, 4, 5, 6 characters, comma delimited. This is the result we get. My next set of examples. This character here places a leading $sign into the number. Here we have another leading $sign with a 0 value, so we have $0. The same applies to the 0.1 value since we've actually rounded it. Here are some date examples. Year converts the year and outputs 2003. Day gives me the day, Tuesday. Month gives me January. DD gives me the 21st day in the month. And YYYY gives me 2003. Using them all together, day, month, DDYY gives me Tuesday, January 21, 2003. In this case, we've actually added the time on as a 24-hour clock. So we have Tuesday, January 21, 2003, 0900 hours, 45 minutes and 22 seconds. In this example, we use the toDate function in a where clause. The date has an internal format, so what we're doing is we're putting in a date. We're interpreting the format of the date for a date data type, and then the show date is assessed as being less than the toDate conversion of the string 0101-2003. In other words, what we're looking for are show records where the show date is anywhere before the 1st of January 2003 or up to and including the 31st of December 2003. So let's run this query, and as you see, we have lots of show dates in 2002. Now let's check the next query where we do it the other way around. All we're doing now, to prove a point, is we're going to run the same query with the where clause being greater than or equal to the 1st of January. And we have a number of records of shows that are dated as being in the year 2003. My next set of examples. This character here places a leading $sign into the number. Here we have another leading $sign with a 0 value, so we have $0. The same applies to the 0.1 value since we've actually rounded it. Here are some date examples. Year converts the year and outputs 2003. Day gives me the day, Tuesday. Month gives me January. DD gives me the 21st day in the month. And YYYY gives me 2003. Using them all together, day, month, DD, YY gives me Tuesday, January 21, 2003. In this case, we've actually added the time on as a 24-hour clock. So we have Tuesday, January 21, 2003, 0900 hours, 45 minutes and 22 seconds. In this example, we use the toDate function in a where clause. The date has an internal format, so what we're doing is we're putting in a date. We're interpreting the format of the date for a date data type, and then the show date is assessed as being less than the toDate conversion of the string 0101-2003. In other words, what we're looking for are show records where the show date is anywhere before the 1st of January 2003 or up to and including the 31st of December 2003. So let's run this query, and as you see, we have lots of show dates in 2002. Now let's check the next query where we do it the other way around. All we're doing now, to prove a point, is we're going to run the same query with the where clause being greater than or equal to the 1st of January. And we have a number of records of shows that are dated as being in the year 2003. Custom functions using PL/SQL. We've already seen the Fahrenheit to Celsius conversion function. All we're doing is we're taking a Fahrenheit number, subtracting 32, multiplying by 5/9 with this block of code. Once again, we'll go to PL/SQL and simply run the script. Here we build the procedure, here we compile it, here we execute it. Remember, set server output on to output from DBMS output put line, set the buffer to 1,000,000 bytes, and pass in 32 degrees Fahrenheit, get out 0 degrees centigrade, etc., etc.